Hi everyone, this is day 1 of section 1.2 from integrated 2 on absolute value equations and solving those absolute value equations. Alright, so we need to first remember from the first section that the absolute value is talking about the distance from 0 and that the absolute value is always positive. Now, there are a few steps when we are solving these types of equations when you have absolute values, and the first one is to get the absolute value alone. Now, what I mean by that is that it's okay if there is numbers being added or subtracted inside of the absolute value signs. However, you do not want any numbers outside the absolute value. Okay, so you don't want any numbers that are on the same side of the equal sign as the absolute value that are on the outside. You need to get rid of those first before you solve for x. Okay, and to do that, you are going to, once you do that steps, you're going to create two different equations. One of them is going to be equal to whatever number it gives you in the problem, and the other one is going to be equal to the negative of that number, so the opposite of that number. Then you're going to solve for x in both equations. Alright, so a simple example, the first example that we have is to solve the absolute value of x equal to 12. Now the first step is to get the absolute value alone on one side of the equal sign, and it already is. So I can go directly into separating this into two different equations now. Now I do that because if you remember from the last section, if I give you, for example, this side note, the absolute value of 3 is going to be equal to 3. Now the absolute value of a positive 3 is also equal to 3. So these are the same. Okay, but I have two possibilities that I can plug into x to give me that same answer. This is why we need to separate them into two different equations. Okay, so for this example, it's going to be x equal to 12 and x equal to negative 12. Now x is already by itself, so these are actually my solutions, and I'm done. Okay, so sometimes you're going to see your solutions like this, or we also use set notation sometimes. So you're going to see this as 12, negative 12, or whatever your solutions are. Okay, so I will take either answer. All right, number 2. Now, number 2, you have positive 3 inside of the absolute value, but that's okay. I'm not going to get rid of that until after I separate it into two different equations here. So I have x plus 3 equal to 5 and x plus 3 equal to negative 5. Okay, all I'm concerned about is before you split it up is what's on the outside. Okay, so here I can just regular solve, and I get x is equal to 2 as one of my solutions. And here I get x is equal to negative 8 as another solution. Example number 3, so now I have something on the outside of the absolute value, so I need to get rid of that first before I split it up into two different equations. So to do that, I'm going to add 4 to both sides. So I get absolute value of x is equal to 22 now. Now I can split that up, so I get x is equal to 22 as one solution, and x is equal to negative 22 as the other solution. All right. They are going to get a little harder. Okay, for example number 4 and 5, I want you to try both of these. Pause the video before I go over the solutions. Okay, so here I am going to divide both sides by 3 because I need to get rid of this 3 that's outside of the absolute value. This gives you 1, so now I'm left with the absolute value of x plus 7 equal to 8. Now I can split that out. So x plus 7 is equal to 8, and x plus 7 is equal to negative 8. Subtract 7 to both sides. X is equal to 1 is one solution. Subtract 7 to both sides here, and x is equal to negative 15 is my other solution. Again, pause for example number 5. Try to solve it on your own before I go over the answer. So here, the absolute value is already by itself. So I can go ahead and split this up. So I have x over 6 is equal to 5, and x over 6 is equal to negative 5. How do I get rid of the 6 that's being divided? Multiply, the opposite of division. So I get x is equal to 30 as my solution. Do the same thing on the right side for the second equation, and I get x is equal to negative 30, and I'm done. Now, there are special cases here that I need to go over. Okay, so, for example, if after the first step of solving, so after you get the absolute value by itself on one of the sides, usually the left side, so you get a function, or the absolute value of a function, equal to 0. So whatever it's equal to, if it's 0, then that means that there's only one solution. Okay, so far we've done examples where you get two values for x. So now if it's equal to 0, you're only going to get one. And the other possibility is if it's equal to a negative number. So if you have the absolute value of a function and it's equal to a negative number, then there is no solution. Now why? Why does that happen? Remember I told you that if you have the absolute value of something and it equals, and it's always going to equal a positive number. Now it can equal 0, that's fine, but it cannot equal to a negative number, because absolute value is always talking about the distance from 0, and that will never be negative, right? If I say, what's the distance between here and North Riverside Mall? That is not going to be a negative distance. I can't say that it's negative half a mile. That does not exist. So that's why there are no solution, or there is no solution when you are taking the absolute value of a function and it gives you a negative number, or it's equal to a negative number. Now, I'm not saying that x will never be negative. That's not what I'm saying. I'm saying that the whole thing as a whole, inside of the absolute value, if it gives you a negative number, or if it's equal to a negative number, that is not true. All right, so let's go ahead and do a couple examples so that you guys can visualize this. Okay, so the first one is to solve the absolute value of x plus 2 plus 8 equal to 8. The absolute value is not alone, so I need to get rid of this positive 8 by subtracting it to both sides. So I get the absolute value of x plus 2 equal to 0. Okay, so at this point, because it's equal to 0, that's a special case. I will only have one solution here. Because if I create another one, I can't say that I have negative 0. That does not exist. Okay, so this is the only one I am solving for, so x is equal to negative 2 is my final answer. And last but not least, I'm going to get rid of this 3 first. Gives me 0 on the left side. I have the absolute value of x plus 4 equal to negative 3. This here also does not exist, because the absolute value of anything, I don't care what x is, cannot equal to a negative number. So this is no solution. And that is all for day